Today's presentation is going to be focused on proposing an alternate method for landscape controller testing. And Mark Crookston will be the main presenter, who's a semi-retired water engineer from Northern Water. He's got lots of experience in the industry and worked with Northern Water since 1986. He's involved in many professional organizations such as the Irrigation Association, ASABE, USCID, and contains many certifications, as you can see there on the screen, within the irrigation space. Our other presenter today is going to be Brent Meekum, who is a retired industry development director from the Irrigation Association, who also worked for Northern Water. Just like Mark, he has several certifications and lots of irrigation experience. And so today, I'm going to turn it over to them and let them begin their presentation about an experiment that occurred over the last 2 years at the Irrigation Innovation Consortium headquarters located here in Fort Collins, Colorado. So without further ado, Mark, would you take over?
Very good. I wanted to point out that Brad has been working on updating the SWOT testing protocol for multiple years. And the Irrigation Association partnered with ASABE towards making an ANSI standard, national standard, and hence ASABE X627. And we'll have Brent talk more about the progress there towards the end. The current version of ASABE's X627 includes both the original 2008 testing protocol, now referred to as test method number 1. It was created by the Irrigation Association Smart Water Application Technologies, or SWAT committee, along with now a proposed new alternative test method number 2. Test method number 2 was utilized in this 2019 testing of the Irrigation Innovation Consortium, whereas test method 1 is the original one utilized by EPA in their water sense certification. But significant advancements in irrigation controllers have been made in the last decade, supporting improved irrigation management, water conservation. To recognize this progress and encourage additional development, an alternate testing protocol has been developed. This alternate test method places renewed emphasis on deep and infrequent irrigation to take greater advantage of rainfall and better support low water use plantings. Now, the controller testing equipment was moved from Berthoud to Fort Collins. And when that was done, the capacity for testing was increased to a total of 24 controllers, each having 6 zones or stations. The alternate testing protocol increases the testing period from 30 days to 90 days and is consequently a more rigorous test. As the purpose of the 2019 testing was principally for validation of the alternative test method, it included replicates of each controller. Usable data was successfully obtained from 22 of those 24 controllers. 8 controllers used on-site weather sensors, while 14 controllers utilized Wi-Fi internet for weather data sources. All controllers tested had already achieved the WaterSense label. Replicates of the Wi-Fi controllers of the same make and model were programmed for different virtual locations in northeastern Colorado. So we've tried to make the testing as defensible as we could and to learn as much as we could from what was going to be accomplished. Each controller make and model was given a test ID ranging from A to J. When comparing controller performance, the results from available replicates were averaged. 4 of the controllers utilized the wireless sensors, which were installed at the consortium. And 6 of the controllers utilized Wi-Fi internet. And essentially, those controllers could be located anywhere and obtain their data for a designated location from a weather station or a network there, and the testing could be successful. Now, this photo shows the setup of the equipment that was utilized in 2019. The large test board back in center holds 16 controllers, and the smaller test board to the right holds 8 controllers. The output wiring from each controller was connected to Phoenix contact relay switches that were in turn connected to a 16-port Campbell Scientific I/O module, and then to either a CR1000 for the large test board or a CR800 Campbell Scientific data logger on the small test board. Both data loggers were equipped with cellular modems, And the Wi-Fi irrigation controllers were provided connectivity via T-Mobile hotspot that was in the same building. So the required reference ET that you need to do this testing was all obtained from 3 regional weather stations. 2 of the stations were part of the Northern Weather Network in northeastern Colorado. The 3rd station was a new install that we did at the consortium in Fort Collins. 15-minute weather data was validated through a QA/QC process and then aggregated into hourly data. The X627 protocol uses an hourly time step. The hourly data was then processed through RefET version 4.1 to provide a reference ETO. And the only weather of the 3 weather stations that had a weighing bucket was the one at Berthoud. And that kind of device typically has some bounce in its readings. And so it was post-processed to remove that signal bounce that's so common. And then its data was essentially mimicking the discrete rainfall events of a 0.005 inch tip rain counter. So this is the Fort Collins East Weather Station at the consortium. It used a ClimaView 50 from Campbell Scientific. It was provided to need the reference data for the controllers that were utilizing on-site sensors. It's very compact. It has no moving parts, so there's very low maintenance or service requirement. Yet it provides weather parameters and accuracy very comparable to more traditional ET networks. With no gill shield, the temperature sensor benefits from onboard corrections utilizing wind speed and solar radiation. Similarly, the drip counter rain gauge has onboard compensation for high rainfall rates, which are typically undermeasured by traditional tipping bucket rain gauges. And it proved its mettle in 2019 with one very high rainfall event. This weather station is the Berthoud weather station at the Northern Water headquarters. And again, it has in fact, you can see the tipping bucket in the background there, the weighing bucket in the background that we utilized for that weather data. This is Roland Moore Park Weather Station. It's in the park owned by the city of Fort Collins. The weather station itself is attached to the scoreboard on one of the ball fields. You can see the foul line there next to it. But the anemometer, the tipping bucket, the air temperature, and solar radiation are all nestled in there together. It's only experienced damage from a home run one time, particularly in the area of smart controllers. Numerous models and options are readily available. Determining which will adequately meet the needs and properly support the objectives for any given landscape, it can be a daunting undertaking. But proposed testing protocol number 2 has good potential to impact the irrigation industry for the better by providing better data in a way that decisions can be made appropriate for any given application. One of the things I want to point out is that I mentioned that some of the wireless sensor controllers, is there still room for improvement? Yes. Significant advancements in improved irrigation scheduling management have made, particularly in the area of smart controllers. Numerous models and options are readily available. Determining which will adequately meet the needs and properly support the objectives for any given landscape, it can be a daunting undertaking. But proposed testing protocol number 2 has good potential to impact the irrigation industry for the better by providing better data in a way that decisions can be made appropriate for any given application. One of the things I want to point out is that I mentioned that some of the wireless sensor controllers may have had problems with connectivity to those sensors. And what happens is the manufacturer specifications for maximum line of sight, their sensors range from 800 feet to 1,500 feet. We had one of the 4 that performed well, and we're not sure why the other 3 didn't, but they were all under 800 feet, but they controllers were inside a metal building. And that's always problematic, and there just weren't resources to overcome that in the limited time frame we had. But that's a good thing to keep in mind with using wireless sensors. Now, moving forward, AB X627 does not establish performance standards for smart weather-based controllers. It just says how to do proper testing. If entities are interested in the benefits of alternative protocol number 2, they either can proceed independently or work collaboratively to establish performance benchmarks. Benchmarks could be simply a pass-fail, or they could be comparative. And at this point, I'd like to invite Brent to add some comments.
So I guess the X627 standard is in the final stages of being approved by ANSI. So within the next few weeks, that should be done. And then, you know, where to go forward. So this was a fairly expensive test to have to perform, and it probably needs to be redone with a different lab and different people to verify that they can get the similar results, and then to try and establish that baseline. So I know with EPA WaterSense program, they established the criteria by which they did a pass-fail. So nobody actually knows how any controller performed on any particular zone. They got a label or they didn't. And so that was just a simple pass-fail, but the criteria they used is what Mark showed. And, you know, that was strongly recommended to them by the SWAT initiative from the Irrigation Association. On this other one was for a longer period of time, and we did from midsummer into the fall. You know, it might be interesting to say, well, what happens if you start in the spring and end in the midsummer? You know, where you got rising ET versus declining ET. Well, I don't have a strong answer for what would the results be. But I think in reality that this idea of 100% perfection is not a reality, that somewhere, you know, around the 80% maybe what we would like to say is a great improvement over what is considered normal by most water utilities, especially in the West, when they're trying to size water mains and stuff. They tend to look around a 60% irrigation efficiency. And so if we can get to 80, that would be a pretty good step forward.